All right, let's just dive right in. Today, we are tackling one of the biggest, gnarliest challenges in all of software engineering. The question is, how do you actually build a system that can handle 100 billion users? And look, this isn't just some academic thought experiment. It's a real-world problem that pushes our technology to the absolute brink.
Just look at that number for a second. Let it really sink in. We're not talking about big data anymore. We're talking about a scale that pushes you into the exabyte domain. And when you're operating up here, you have to make some incredibly tough architectural choices. Because at this level, you're not just fighting buggy code, you're literally fighting the laws of physics.
And that brings us to the fundamental conflict, right? The real heart of our story. On one side, you have what's called strict consistency. This is the absolute guarantee that your data is perfectly correct everywhere all at once. Think of it like your bank balance. It has to be right. Then on the other side, you have maximum throughput. This is all about lightning-fast speed, like a light counter on a video that's going viral. You need it to be fast. And here's the catch. You simply cannot have perfect versions of both.
So to manage this trade-off, modern systems use some pretty clever patterns. One of the most important is something called CQRS. Now, the core idea here is actually pretty simple, but it's incredibly powerful. You separate the system that handles writing data, the commands, from the system that handles reading data, the queries. This lets you optimize each path completely independently. You can scale up your read infrastructure to handle insane amounts of traffic without ever slowing down that critical write path. It's really a key strategy for dealing with millions of users.
Okay, so let's explore our first path. We'll call it the Fortress of Consistency. This is the world of NewSQL, and it's the path chosen by people who demand that financial-grade correctness above everything else.
Our first champion inside this fortress is Google Cloud Spanner. This is Google's own planet-scale solution, and it has this totally fascinating secret weapon, atomic clocks. Yeah, you heard that right. It uses a system called TrueTime to achieve almost perfect consistency across the entire globe. It's pretty wild.
Now, what's so interesting here is the trade-off, right? The pros are huge. You get consistency that is basically second to none, and it's been proven at a scale most of us can barely imagine. But the cons, they're just as big. You are completely locked into the Google Cloud platform, and there's a real physical penalty for all that consistency. Your writes are just plain slower because they have to get consensus from machines potentially continents apart.
And when we say proven scale, we really mean it. In production right now at Google, Spanner is handling over 6 billion queries per second. That is just a mind-bending number that very, very few other systems on Earth can even get close to.
But what if you want that same kind of consistency, but without being locked into one vendor? Well, that brings us to our next contender, CockroachDB. You can almost think of it as the spiritual successor to Spanner, but it's been designed from the ground up to run anywhere you want it to.
So CockroachDB actually solves some of Spanner's biggest problems. Its killer feature is this thing called row-level geopartitioning, which lets you pin a specific user's data to a specific country. That's a huge deal for complying with laws like GDPR. But, just like Spanner, it still faces limits on its raw speed, because guaranteeing consistency just takes time and a lot of resources. It's also really not built for OLAP, those big, complex analytical queries.
Okay, so what if you don't really want a fancy NewSQL database? What if you want to scale the classics that everybody already knows and loves, like MySQL and PostgreSQL? Let's explore that path. This is where a tool called Vitis comes into the picture. It's basically the magic layer that was built inside Google to scale YouTube's massive MySQL databases. It lets you shard or split up your database across tons of different machines, but it makes it look like one giant database to your application. The power it gives you is undeniable, but the operational complexity of running this thing yourself, it's a beast.
And again, this isn't just theory. Vitis is absolutely battle-tested. It's been proven in the trenches at places like YouTube and Slack, handling exabytes of data and millions of queries per second. It's the real deal.
Now for the Postgres world, there's Citus. It's an extension that basically transforms Postgres into a distributed powerhouse. It is especially fantastic for multi-tenant SaaS applications because it can group all of one customer's data together on a single machine, which makes queries for that customer lightning fast. The catch? You have to be very careful about how you model your data, or you can run into some really serious bottlenecks.
And now for our third path, the global superhighway. This is the NoSQL paradigm. This is for when speed and availability are your absolute #1 top priorities, and you're willing to trade a few moments of inconsistency for just unstoppable performance.
And here they are, the titans of that world. Each one of these is a giant in its own right, and they're powering some of the largest applications that you use every single day: Cassandra, DynamoDB, Cosmos DB, and ScyllaDB.
You know, this slide just perfectly captures the essence of each one. Cassandra runs on a staggering 75,000 nodes at Apple, but its Java architecture can sometimes suffer from these unpredictable stop-the-world pauses. DynamoDB literally powers Amazon Prime Day, but it can get prohibitively expensive at scale. Cosmos DB gives you these ironclad guarantees on performance, but you definitely pay a premium for it. And then there's ScyllaDB, which delivers just insane performance, but its core model is eventually consistent, which means that for a brief moment, different copies of your data might be slightly out of sync.
So, we've seen all the different philosophies, but what happens when we actually put them head-to-head? Let's look at the raw numbers, both for performance and, for cost.
Let's just frame this with a really direct question. What is the actual performance penalty you pay for that guarantee of strict, perfect consistency?
Well, the answer is pretty dramatic. In a direct head-to-head comparison, ScyllaDB, our NoSQL champion, delivered over 9 times the throughput of CockroachDB, the NewSQL contender. This right here, this chart, is a perfect illustration of the raw speed you sacrifice in the name of perfect correctness.
Okay, performance is one thing, but for any business, there's another absolutely critical factor. What's the price tag? What does it actually cost to run these systems at the kind of scale we're talking about?
The difference here is staggering. For the exact same workload, DynamoDB is going to cost you about $30,000 a month. ScyllaDB, just $4,500. This just goes to show how your big architectural choices and the raw efficiency of the software can have a massive, massive impact on your total cost of ownership.
So what's the verdict? At the end of the day, there is no single best database. There's only the right one for your specific mission. It's always about the right tool for the right job.
So here's your mission briefing. If you are building a financial ledger and you need absolute, unshakable correctness, CockroachDB is your champion. If you are all in on the Google Cloud ecosystem, Spanner is just unmatched. Building a multi-tenant SaaS app, you go with Postgres and C2s. And if you need the absolute maximum throughput at the lowest possible cost to get to that 100 billion user scale, well, ScyllaDB is the clear choice.
And that leaves us with one final question for you to really think about. As your application grows, and it will, the choices you make today are going to determine your limits tomorrow. So ask yourself, is your database really built for the future that you're aiming for?